Today, let's talk about Leetcode Weekly 429, question 4. First part is description. We are provided string s which contains 1 or 0. We also have an integer num ops. We can do some operations to this string. For every substring, we can choose index I and flip si. Flip it, and that means we can become it from 0 to 1 or 1 to 0. Our target is we can do this operation at most num ops times. Our target is minimize the length of longest substring which have the same character. For example, if the string is 110110000, so the longest substring which have the same character will be 111. So the length it will be 3. What we need to do is after at most num ops operations, we should make the length of longest substring as small as possible. This is our target. Next part, let's talk about solution. In this part, if the answer is 1, that means the after do the operations, the results of the original string should be two kinds of way. First will be 0 1 0 1 0 1 0 1 da da da, or it also can be 1 0 1 0 1 0 da da da. So we can check for the two kinds of situation. We can check how many operations we need to do. If the operations that we need is less than num ops, that means the answer should be 1. That means we can get a string after flips, after operations, and the length of longest substring can be 1. In contrast, if the answer is larger or equal than 2, we can solve it through binary search. That means the least possible answer should be 2, and the largest possible answer will be a star size. So every time we can check the target. The target will be L plus R and divided by 2. So for the target, what we need to do is how many operations we need to do if we want to change the string into another string which the length of longest substring which have the same character should be target or should be less than target. How many operations? If the operations we need is less than num ops, that means we can realize target. We can search the results from L to target. In contrast, if the answer is larger than target, that means there is no as much operations we need. That means operations is larger than num ops. Okay, let's make it clearly. If the operations is less than operations we need num ops, so we need to search the answer from L to target. In contrast, if the operations we need is larger, there is no equal. oops, we need to search the answer from target to R. This is how we update the range of binary search. This is first step. Okay, next step is how to calculate how many operations we need. In this part, we can process something for the original string. If the original string will be 1100 1111 00 000. If the original string we can get a array. That means we can get an array. There are 2 0, so it will be 2 2 4 3. We get an integer. The element of the integer shows how many adjust character in the substring. So what we need to do is flip some characters and reduce the big integer, become smaller. For example, we need to become it to target. If target is 2, we need to flip some character, become the 4 into 2. If the 4 is 0 0 0 0, that means we need to change this 0, the second 0 or third 0, and become it into 0 1 0 0. So the length of length of longest substring is 2. That can meet our requirement, that can meet the target. So we need to process the original string and get an intermediate array. So for the every element in the array, we need to calculate how many operations we need to do and become this element into target. This is the key point of the problem. We can try to find the best situation. I mean, for example, if the target is 2 and the element is 8, we can take 8. That means there are 0 0 0 0 0 0. That means the target is 2. That means we can allow the first 2 0 are allowed, but the third should be flipped into 1, and the next 2 is also allowed, but the next is also should be flipped into 1, and there can be 0 and 0. So if the element is 8, the operations we need is 2. This is the best situation if the secondly, if the element into 9, I mean, okay, 0 0 0 0, this should be flipped 1, and there is another 1, that means we also needed to flip this 0 into 1, so we need to do another operations. So if the element is 8 and target is 2, this should be the most efficient situation. So how many times? The times should be element divided by target plus 1, because we are allowed target zeros, but we also need to flip 1 time, do 1 operation. So this is y plus 1. So for every element, the times of operations we need to do it should be element divided by target plus 1. So so for this problem, we can sum of times. We can, if the sum of times should be how many operations we need to do. We need to check this is less than num ops or larger than num ops. So for every target, we can calculate how many operations we need to do and check the times is less than num ops or larger than ops. If it is less than ops, we need to search the answer from L to target. In contrast, we can search it from target to R. This is how we solve this problem. This is the solution part. If you have any confusion, welcome to submit a comment. Next part is complexity. First is time complexity. For the binary search, the range of binary search should be 2 to s size. We can make n equal s star size. I mean the length of the string. So it will be the binary search should be log n, and for every target, the times we need to calculate is should be n. So the final time complexity is n log n. This is time complexity. For the space complexity, we need to store another array, integer array. So the space complexity will be on. Okay, this is all about this problem. If you have any confusion, welcome to submit a comment. Thanks for your watching.